Okay, before we start our first section here, I want you to know you probably should be using your guided notes here. So they look kind of like this, handed on a packet for the unit. And so as you go through, you should be able to write on these, determine the best graded class. So answer your questions here on the paper. I highly recommend that as you're going through, just filling out the guided notes for the lessons. So here I'm going to do two lessons in one. So 1A and 1B. This is really our first week of AP Stats here. And so just watch the screencast and buckle up. Here we go. So we're going to learn, this is a new skill actually for AP Stats, determine a valid investigative question. Identify the population sample. We do that a lot in stats. And then finally the observational units and variables, and just kind of describing those. We'll learn all about those kinds of things. Okay, the first thing is usually stats start with some kind of investigative question. We're answering something that seems kind of interesting. It's based on data that varies. That's what stats about. If there's no variation, we don't really have statistics. Statistics is based on the idea that things vary, even things you don't think would vary. Like if you buy a 12-ounce Diet Coke can, it doesn't have exactly 12 ounces in it. It just doesn't. It has maybe a little bit more, maybe a little less. You could investigate it, but it probably doesn't have exactly 12 ounces. So everything varies. Here's a question. Can Joy correctly identify Parkinson's disease status by smell for more than 50% of all shirts like the ones in the experiment? So this was a question about she could smell a shirt that was worn by someone who may or may not have had Parkinson's disease, and she claims that she could smell Parkinson's on the shirt. And she actually could. Is this a valid investigative question? I think it is, right? That's a great question. What is the world record for the 100-meter dash? It's kind of a trivia question, not a stats question. It's not an investigative task. There's one answer for that. It's not something we have to investigate. It's just a yes or no kind of question. Okay. Determine the investigative question. So this is, again, a new skill for AP Stat. We haven't done this before, so this isn't that hard. In the 70s and 80s, actually, I remember this. I would go to the grocery store. They would have a stand set up, and they would give you free taste tests. Well, I love free stuff, so I would do this. You had two different cups. So you drank one and drank another, and you told them which one was better. You didn't know which one was Coke or Pepsi. It was a blind taste test. And you tasted them, and then you said which one it was. Most people, interestingly enough, pick Pepsi. The way they did it in the store, it's a little sweeter drink, and without food and other stuff, it actually seems to come off better than Coke does. And so what is the question? So, I don't know, maybe blind taste test. Well, maybe more than half or the majority of folks pick Pepsi. This is called the Pepsi Challenge. So, will that happen? Do the majority of U.S. cola drinkers prefer Pepsi when given a blind taste test against Coke? And so that's the question. And that is a statistical question. The answers are going to vary. We don't know what people are going to say. Populations and samples. So the second part of our lesson. Collect data samples in order to investigate questions from about larger populations. We do this all the time, right? So the population, a lot of stats is just learning the vocabulary here, especially this first couple lessons. A lot of vocabulary. Population is the entire group, maybe all of St. Mary's students, all the students in high school. A census, that's the population. A census would be to ask every single person a question or collect data from every single person. That's a census. A sample is when you're like, I don't have time, the energy, all that stuff to do every single person. So I'm going to just take a small sample, hopefully a random sample, but a subset of all of the high school students at St. Mary's. It'd be nice to maybe grab, 5 or 10, maybe 10 freshmen, 10 sophomores, 10 juniors, 10 seniors, randomly chosen, and ask them the question of interest. Why would research to do a census every time? It's so expensive. right? The United States does every 10 years, and it's so expensive. We're pretty much almost as accurate as a census is if we just take a nice random sample, and it's so much easier to do, less time, less costly to do than a census. It's just better. Identify the population and the sample. So let's look at a couple examples. This is where it hits home. If you want my word of advice, I strongly recommend starting with the sample and then going to the population. The sample is usually somewhat obvious, so then you have to just ratchet up a notch. So I'm going to do it that way. To estimate the average length of time a patient must wait in the ER of a hospital during a given week, hospital staff record how many minutes it takes for each of 50 patients to be treated by an ER doctor or nurse from the moment the patient enters the ER. So they took a sample of 50 patients and asked them about the wait time. So I think maybe the sample is I'm hoping I'm right, the wait times of the 50 patients, and the population is the wait times of all the patients in the hospital who are in the ER. Yes. Is all patients who visit the ER during the week. Samples of 50 patients. Oh, so this is interesting. So I said it was the wait time of the patients. Actually, the population is the people here, right? It's the patients who visit the ER. The sample is the 50 patients who they did time, but the sample is the patients here. So it's not the wait time of the patient, it's the patients. Bad. Okay, company is hired to check lifeguard readiness by a local community pool. Company obtains a schedule of lifeguard shifts for the next 2 months. From that schedule, the company selects 20 different shifts during the lifeguards will be given an unannounced test of their skills. I kind of like that, doing an unannounced test, see if they can really do it. So start with a sample. This one, it's pretty clear, I think. So the 20 different shifts for the lifeguards. So they sampled 20 shifts for the lifeguards. So the population would be all the shifts for the lifeguards at this particular company. All lifeguard shifts over the next 2 months. Maybe I should include the time there. The sample is the 20 shifts selected for the unannounced tests of lifeguard skills. Okay, statistical study. The sample size is represented by lowercase n. That makes sense. And the population is uppercase n. Okay. Parameter is statistic. This is important stuff. Parameter is a number that estimates or describes some characteristics of a population. Parameter describes a population. A statistic describes characteristics of a sample. So I think it's helpful to remember this. I think they call this alliteration in English. Population parameter. Parameters are like, of all the girls in the United States, the parameter, you might measure the height, the average height of all the girls in the United States. So the parameter is the average height. The population is, all the girls in the United States. The sample is you took a random sample of all the girls in the United States, maybe 5 from each state or something, and then you measure the average height of those in the sample, random sampling. Okay. Most data tables follow this format. Each row is an observational unit, and then each column is a variable. Or maybe the first column is the observational units. You might think of it that way, the way a table kind of works. You'll see in a second. An observational unit is an item or individual described in a data set. Variable is a characteristic that can take different values for different observational units. So you think of observational unit as a person or a thing which you're studying. A variable is you're collecting some percentage or measurement or something about those observational units. Good example here. Okay, so it said, if we look back here, each row is an observational unit. So that first column there, the households, those are the observational units. So, there's household 1 as a unit, household 2, etc. So all the other columns are the variables, right? So from region all the way to internet access, those are all different variables. Two types of variables. Region, time of dwelling, response made, internet access are all categorical. The number of people in the household, dollars is quantitative. So here's the definition of those two descriptions. So categorical, I like the word, you're grouping them in a category or into a group by some label or something. Whereas quantitative, you're counting or measuring. So quantitative is more numeric, usually. Categorical is more, words kind of thing. But again, you got to be careful. Categorical or counts or measurements. I like those descriptions a lot there in that wording there. Sometimes they call them qualitative. It's not the new name for this. Not all variables take number values. So just because it's numeric does not mean it's quantitative. Like a zip code, 38117 is a zip code for our school. That's people who live in this area, or businesses in the area are all in that same zip code. You're categorizing people by, okay, the table displays information from a sample of 10 randomly selected large airports around the world. What are the observational units? Well, it kind of says it in the description there, the sentence we just read. Also, if you look at the very first column of data there, that's the kind of the rows there. Those are like 10 different airports, 10 randomly selected airports from around the world. I only recognize a few of those, but some of those maybe you've been to. So those are the observational units. So the rest of the columns are the variables there. So variables are all those different things. So which ones are categorical and which ones are quantitative? And I don't think this one has anything too tricky. So number-wise, probably elevation. Is that something that's counted or measured? Sure, you would measure elevation, I would think. Radio frequency gets counted or measured. Runway length, counted or measured. Those are measured. And then the other ones, the word ones, municipality, those are categorical. County is country is categorical, and runway surface categorical. So again, these are categorical ones. These are quantitative. So nothing really tricky there. Sometimes they're tricky. You got to be careful. There are two types of quantitative: discrete and continuous. So think of discrete. If you've taken calculus, you might understand the word discrete. You're kind of jumping from 1 to 2 to 3 to 4. It's like counting. Whereas continuous, you might be measuring something. Height, weight, anything you measure can be continuous. You have numbers in, you might not be, might say like I'm 175 pounds. No, I'm 176 pounds. Actually, in between 175, there's numbers in between those values. You don't just count from one to the next. You could be 175.5876. Like, there's no limit to how much of is your scale, how accurate it is. It's a continuous measurement. So measurements are continuous here. Again, take a set of all possible values with gaps between them. So think of discrete as counting or having gaps between them, whereas continuous, anything on the interval counts. Anything on a number line will count. Number of siblings. You can't have really half a sibling, right? So it's a discrete thing. Time is continuous. That makes sense, right? You could, 9 seconds, 10 seconds. Well, you could do 9.587. You can have continuous. You don't just count by ones and twos there with time. It's continuous measurement. Okay, we're to the second part. So this is part B. We're rolling here. Okay. These aren't too bad, just a lot of vocabulary mostly. Make and interpret a frequency table or a relative frequency table. Make and interpret bar charts or pie charts. And compare distributions. So we'll talk about all three of those. And also identify what makes some graphs, what are some misleading graphs. That can happen sometimes in the real world. Okay, so now we're talking about displaying and describing categorical data. Remember, data can vary. That's what we're describing. That's what we're doing. So the distribution is how that varies. What's the shape of it? Well, all that kind of stuff. So the distribution tells us the values the variable takes on and how often that happens. Okay, today's focus. We're going to do categorical today. And this is called descriptive statistics. I don't think you have to know that. Okay, there are two different types of these types of categorical variables. We use a frequency table or a relative frequency table. Frequency table shows the number of each grouping there, the variable, and then a relative frequency shows the percentage there, or the proportion, but really the percentage usually. Okay, great question here. Which fast food has the best chicken sandwich? Here are the responses. Make a frequency table and a relative frequency table to summarize the data. So to do this, you would first put all the different categories in a table. Restaurant, so you would put the name of all those, Popeyes, and you would count how many Popeyes. If you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think there's 14 Popeyes. Shake Shack, by the way, Shake Shack is the best. Although I will say this, I've tried their chicken sandwich and it's good. Everything at Shake Shack is good, but I don't know if it's quite the level of Popeyes. Okay, so Shake Shack, you count the number of Shake Shack, there's 6 of them. Chick-fil-A are 5, KFC 2. Total of 27. So you've got 27. I always like to make sure it adds up to the total there. So I did it right when I counted them. So this is a frequency table. It's pretty easy to do. You just have to be careful when you count. So what's a relative frequency table? So now, so what you would do is get your calculator out. So I have my calculator over here. And so you would type in Popeyes is 14 divided by 27. If you put a decimal point in the problem on this, it'll give you decimal. The other way of doing that would be, if you don't have the decimal down there, is hit Control Enter, and that gives you decimal. So Control Enter is the approximate symbol there. So, and they want to see that little bit of work. I know that sounds funny, but we like to see 14 divided by 27 equals, and I'm really okay with 0.519 or 51.9%. A lot of times we just leave it at 0.519, but we love to see that little bit of work. I know that sounds funny, but 14 divided by 27 equals that. That is what we like to see in stats. It is showing your work time. 6 divided by 27 gives you that. Do it for each of them. It should add up to 100%, right? That's what should happen because you have all 27 represented there. The question becomes, and percentages are usually easier to answer some of these questions. Do the data support the claim that majority is more than 50%? Yeah, majority more than 50% know the truth. Popeyes is the best here. Customer service, not great. Not like Chick-fil-A, but the sandwich itself, if you don't mind waiting in line, pretty good. Okay, so yes, and then they gave the reason there. Frequencies and relative frequencies listed in the table are not data. The frequency and relative frequency table summarizes the data by telling us how many or what proportion or percentage restaurants are choosing as having the best chicken sandwich. It summarizes categorical variables distribution. A bar chart is a graph of data for one category variable that displays each category as a bar. The height of each bar shows the category frequency or the relative frequency. Tend to prefer relative frequency, but they do it both ways. Talk about bar charts, and we're going to get the pie charts too. So this one, if we take this data here about the preferred method of, communicating, maybe by teenagers or something, I'm not sure. There's the data, and they did it by percentage right there. So you can see that the 24%, the bar goes up to about 24% there. So the next one goes up to about 12. Next one goes up to about 2. So they tried to make the bars as accurate as they could. Notice the scale on the left just goes 0 all the way up to 60, just in equal amounts, and then you just draw your bars. If you want to color them, they can do that as well. This is a really nice, I really prefer to look at a bar graph rather than a table of values. It doesn't pop as much. It's easy to see, oh man, text messaging. A lot of people really like that. In person, it's pretty popular as well. Phone call. Evidently, no one makes phone calls anymore. I'm not sure what's happening there. So a total of 55 modern Olympic Games have taken place since the inception of 1896. The Summer and Winter Olympic Games are usually held about every 4 years, excluding the games canceled by World War I and World War II. Frequency tables summarizes the distribution of the region of the world in which these events are hosted. Make a relative frequency bar chart to display the data. Describe what you see. So to do that, you would get your calculator out and you would go 8 out of 55, put a decimal point. So 14.5% of the games were hosted in Asia, for example. You would do that for each one of them. Again, you want to show the work, 8 divided by 55, 0.145. Do that for each of them. Beautiful. Now you want to draw your kind of L-shaped graph, the X and Y axis, so to speak. Label, see which one needs to be on the bottom here. Those will be it looks like the 5 different regions there. So region of Olympic Games host. And then on the left, you want to scale it out by percentage. So 0 all the way up to, you don't have to go up to 100 because none of these are higher than 58%. So you go to at least 60%. So as they start at 0 and all the way up to 60%, that's a fair way to do it. They wrote relative frequency, and notice that it's fine to do it with decimals. We don't mind those, or percentages if you'd rather do it that way. And they just scaled them out. If you're up to that level, bar charts are normally not connected. It's kind of an important little nuance here. You might get wrong at first, but bar charts, categorical variables, they're separate categories, and we do a separate bar for each. Then you can answer the question. Describe what you see. Wow, Europe hosts a lot. Modern Olympic Games have been hosted most often in Europe, more than twice as often as the next most common. Wow. North America is 21.8%. South America, not very many, right? Okay, pie chart. So you've seen one of these guys before. It's a pie chart. It has to add up to 100%. That's probably one of the most important things about it. So you're kind of taking each category's relation to the whole. Each slice of the pie, how big the pie slice is. That angle, that bigness is big deal. So you're going to justify a claim about the variable, potentially. So make sure you include all the data sets. This is about 100% of the data. So if some of them don't have a name, just put it in the other category and you're good there. Side-by-side bar chart is a graph of data on one category in each of 2 or more groups displaying the bars. It's really nice to use like colored ones or shaded appropriately. Use relative. If you're comparing 2 different size groups, it doesn't make sense to use frequency. So use relative frequencies, use percentages when you're comparing data. That's a good idea to do. It's a little hint there for you. And this one, this is nice, right? So we have color-coded. In the 30s is green. Wow, I don't even see green represented on the 60 to 69-year-old. Oh, wait, this is, let's see, what's this about? As a random sample of U.S. adults, what they thought the best age for a U.S. president would be. Summary's response of 18 to 29-year-olds. So, wow, so 18 to 29-year-olds said there should be about 10% said, hey, somewhere in the 30s. Whereas none of the 60 to 69-year-olds said in the 30s. The young folks said only like about 1% maybe would be in the 70s, who I think were there. And then the 60 to 69-year-olds only said about 5%-ish would be in the 70s. So just a different, kind of interesting little graph there. You can compare it. The 60 to 69-year-olds tended to prefer older presidents. That's a generalization, which I think is true to some degree, up to a point. The most popular age for presidents is the 50s for both age groups. That's kind of interesting to kind of compare. Sometimes it's not saying they're different, but just make a comparison or what's the most common. However, the older age group was much more likely to say the best age is in the 60s, 39% versus 7%. They knew the exact percentages there. And in the 40s, again, so if you're younger, you're going to want more. The 40s, really a huge difference there in the two. The president of the 70s was also unpopular with both groups, but older groups chose it more often. Oh, I really like this. When they say the word compare, please use words like one is larger than another. Don't just say one is 39 and the other is 7. Say 39 is greater than 7. Like, use words like one is bigger than the other, or more often, or more likely, or not as popular. So use comparative words or to get full credit at the AP exam. It's a very nice hint for you. Okay. Possible compare distributions using only a relative frequency table. Okay. So here's, this is categorical data, right? Less than 2 hours, even though it looks like numeric, you're categorizing time into categories every 2 hours or whatever here. So different categories of time. And then age groups are teens and tweens. So they said teens and tweens are the bottom of the age group, and then the percent are as follows. So they color coded it. It's very nice. You can talk about it. You also could, if you wanted to, instead of making it the age group are like the two variables in the bottom, you can make the daily screen time that. And then the age group would be the little, like in the key here. So you have to make a key. It's very important to make a key. You could do it either way. Like either way is acceptable here. Kind of highlights different things. I think if you do it different ways, you're really comparing the tweens to the teens a little bit more when you have side by side like that on the right. On the left, it's a bigger picture. You can see it all together. How do the teens feel? How do the tweens feel? So forth. Always remember to include a key there. Finally, I think this might be the last thing here. So misleading graphs. This happens in the real world, I promise. Magazine articles, advertising, they do this all the time. So don't do it. This is bad. These are called pictograms. Weathermen use this. They might do a snowman. I see this on TV sometimes. And it's very bad. So here, the problem is the height. First of all, say for United States, if you see that satellite thing, where's the top? Is it at 4,500 or 4,000? Like it's kind of slanted at the top, so it's really tough to see. And so I don't like that part of it. The other thing is just the area. I kind of mentioned here, the area of the bars affects the way we look at things. So like if you think of like the United Kingdom there, how many of those little guys could fit in that big thing there? It's so much bigger. The area, the width of it is bigger, not just the height, but the width. We don't like that. The width should not change for each of the figures. The height can change. That's what a bar does, but the width should remain the same. It's very misleading. The total area of the satellites make it seem like the United States owned dozens of times larger, like 100 times larger, like crazy amount. But that's not really true, actually. So 2, 3, 4, 5, 6, 7, about 7 times as much as what it should be. It looks like 50 times as much, right? It just looks very deceiving. What's wrong with this one? So explain why this one would be deceptive. And it doesn't start at 0. Isn't that weird? Like, don't you think percentages go 0 through 70 there or something? So it's going to look a little weird because it looks like the other communities have very small amounts. Still look like China and the United Kingdom must have 0. May or may not be the case. Because you can't see below 10%. Maybe they both have 5. We don't know. So so very misleading. Okay. That's your lesson for today. I know it's kind of a long screencast, but it was 2 lessons in one. And now hopefully you're ready. You can do your homework and get ready for that quiz coming up later.